Welcome to the demonstration of Experiment 1, called Dynamic Resource Allocation via Federations. This presentation will illustrate how federations optimize resource allocation in a dynamic environment, addressing some of the key challenges in 60 networks. So the primary objective of this demonstration is to showcase how federations dynamically allocate resources in response to changing conditions. By simulating a 60 environment, we aim to highlight the adaptability and efficiency of this approach. So this demonstrator integrates real-world measurements with detailed 3D simulations to showcase the system's capability to adapt federations dynamically and optimize resources in real time. These features are tailored to meet the requirements of various applications in the 60 context. So the goal of the demonstration is to validate the feasibility of federation-based resource allocation, analyze critical performance metrics like energy efficiency and data rate stability, and illustrate how federations scale in dense environments. This serves as the foundations for future 60 implementations. Now, this demonstration is centered around two primary components: the Lunity simulator and the federation orchestration work that's been done in this project. Luntism provides a realistic and efficient simulation environment for the wireless aspects, while the federation orchestration dynamically manages resources allocation to optimize performance on a system level. And this demo is at the intersection of these two. Let me first explain what Lunity Simulator does. So Lunity Sim is a state-of-the-art simulator designed to address the complexities of 60 of 60 wireless environments. It features advanced channel modeling using geometry-based stochastic channel models and raycasting to accurate multipath propagation. The simulation builds realistic 3D environments, including urban and indoor scenarios, using Unity's rendering capabilities to process cloud data points. We can also leverage GPUs to accelerate. And both CPU and GPU. So Lunity Sim achieves very high computational efficiency, and it outperforms traditional simulators or competitors like Siona. So here you see an example of an industrial industrial environment that's been imported into the simulation framework. And you can see so here in the simulation been paused, and we can pan around. The purple dots on the walls are CSPs, and they're distributed. There are 32 on either side of this environment. And some of the rays they can see are some of the rays that have been cast from those CSPs to uh, to the UE that's in the middle, where those yellow points converge. And so this capability is vital for active modeling complex environments, and we'll put it into use in a short while. So the federation orchestration algorithm, the second component of this demonstrator, is designed to optimize resource usage in cell-free kind of massive MIMO systems. Its primary objectives include minimizing energy consumption, ensuring data rate compliance, and managing scalability in dense user environments. The algorithm adapts dynamically to real-time conditions, balancing centralized and distributed architectures while integrating hardware-aware energy models. So then let's put this to use then. So here you see the simulation action. The video illustrates the setup of 64 CSP suspended from the ceiling in that industrial hall I showed you just before. You can see that the federations adapt dynamically as users' equipment move through the environment, and you can see that in the chart to the chart to the lower left, where the dots are on the lower side of the figure. The bottom of the figure are the CSPs moving around in a pattern. The triangles at the top are the different CSPs, and you can see the colors represent which CSP the users are associated with, the federation that they're associated with, and then also which federation the CSPs are associated with. And the gray triangles are CSPs that are not utilized. The figure to the right of that is represents the throughput of the system. As you can see, as it evolves over time, you can see the throughput that it's getting in over time. To the right of that, you see the federation stability, and here we define federation stability as the amount of time that a federation is consistent for a user. So you see that has converged very quickly. Above that is the number of active CSPs in the system, and above that is the total power that is being output through is through the system. So this simulation demonstrates the real-time capabilities of the simulation as they work together to handle these dynamic resource allocation scenarios. So then, what are the key takeaways? This demonstrator showcased how federation-based resource allocation dynamically adapts to real-time changes, achieving energy efficiency and performance stability. The scalability and adaptability of this approach position it well as a vital enabler of future 6G networks. Thank you for taking the time to listen to this presentation.